Chapter 7: The Feed-Forward Network. Attention, let words share information. Now each word takes a moment to think for itself. Let's meet the other half of every transformer block. Every transformer block has two stages. First, attention, where words look at each other and mix. Then the feed-forward network, where each word is processed on its own. Here is the key detail: the very same little network is applied to every position separately. We call it position-wise. Attention connects, the feed-forward network computes. The network itself is refreshingly simple. Just two linear layers with a nonlinearity in between. The first layer expands the vector to a much bigger size. The activation reshapes it. The second layer shrinks it back to the original size. Expand, activate, contract, that is the whole structure. Let's follow the sizes. Our vector comes in with, say, 512 numbers. The first layer blows it up to 2048, 4 times wider. Why room to work? In this larger space, the network has enough dimensions to detect many subtle features of the word and its context. In the middle sits the activation function. It applies a simple nonlinear bend to every number, often one called GELU. This nonlinearity is essential. Without it, stacking layers would collapse into a single linear step, and the model could never learn anything curved or complex. We will give activations their own chapter next. Then the second layer brings us home. It projects the 2000 wide vector back down to 512. Same size as we started, so the block's output can flow straight into the next block. The vector that comes out is a richer, more processed version of the one that went in. One more thing worth knowing. These two big matrices are where most of a transformer's parameters actually live, often 2/3 of them. The weights are shared across every position, but applied to each word separately. Think of it as each token asking, given everything I now know, what should I become? So the feed-forward network. Applied to every position on its own. Expand, apply a nonlinearity contract. It is where each word does its private thinking and where most of the model's knowledge is stored. But that little nonlinear bend deserves a closer look. Next, activation functions.